A parking lot charges $3 to park for the first hour or portion thereof, and $2 for each additional hour or portion thereof. Create a table of values for the situation, and then produce a graph showing the relationship between the time parked, T, in hours, and cost, C, in dollars. What are the domain and range? Does the relationship represent a function? Is it appropriate to connect the points? Here we need to first create a table of values. To do this, we have to determine values for the dependent variable, in this case the cost, for several values of the independent variable, the time. We then label the axes. Make sure that the independent variable, the time, is plotted along the x-axis, and the dependent variable, the cost, along the y-axis. We then scale the axes. We want to make sure that we can fit all of the points on the grid provided, but also use up as much of the space as possible. We then plot the points. We only connect the points if it is reasonable. This means if the variables consist of all real numbers between the plotted points. First, we'll make our table of values. The time is the independent variable and the cost the dependent variable. For parking 0 hours, of course it's not going to cost anything, so the cost will also be 0. As soon as we have parked, even for a single minute, all of a sudden the cost jumps to $3. After parking exactly 1 hour, but not yet into the second hour, the cost is still $3. As soon as we park for even 1 more minute, or even 1.5 hours, the cost goes up an additional $2, going up to $5. At exactly 2 hours, we still haven't gone up yet. It's still $5. It then goes up an additional $2 within the next hour. At 2.5 hours, it goes up to $7. And then at 3 hours, it's still $7. As far as labeling the axes, along the x-axis, we have the time, again, the independent variable, and along the y-axis, the cost, the dependent variable. For the scales, first, the time. We have the time going from 0 to 3 hours, and we have 14 divisions on the grid. This means we can use 0.25 hours per division, or 1 hour for every 4 divisions. For the cost, it goes from 0 to $7, and we have 16 divisions. This means we can use $0.5 per division, or $1 for every 2 divisions. We can then plot the points, 0, 0, 0.5, 3, 1, 3, 1.5, 5, and 2, 5, 2.5, 7, and 3, 7. For the domain, of course, corresponds to the possible times. Of course, the time has to be greater than or equal to 0. However, there are no restrictions on the time. It can be all real numbers that are greater than or equal to 0. For the range, note that the range consists of only discrete quantities. It can consist of 0, 3, 5, 7, and so on. Note that each time it goes up by 2. In this case, it is starting at 3 and 0, only the odd whole numbers. Is it appropriate to connect the points? We have to ask ourselves, can we have values between the points on the grid? In this case, the answer is yes. However, only in the horizontal direction. Therefore, we can only connect points going horizontally, and then we jump from $3 up to $5, and then again connect the points horizontally. Finally, is this a function? In this case, we ask ourselves, for each input value, is there one or more than one possible output value? In this case, each input value only gives one output value, so this is a function. This particular function actually has a name. This function is called a step function.